Section 11.4, Binomial Probability. Binomial probability. A binomial experiment has two possible outcomes, success or failure. A repeated performance of a binomial experiment is a Bernoulli trial. A random variable x is assigned to the possible outcomes. A probability distribution lists all possible values of a random variable x and their probabilities. The sum of the probabilities in any probability distribution is always 1. Example 1. Construct the binomial probability distribution for tossing 2 heads with 3 coins. We're going to go ahead and draw the tree diagram that goes with this. When we flip our first coin, our options are heads and tails. And our probability of getting heads is 1/2. And our probability of getting tails is 1/2. After flipping that first head, we then flip another coin and we can get heads or tails. And 1/2 is our probability of flipping a head, and 1/2 is our probability of flipping a tail. Again, heads or tails, and 1/2 and 1/2. So 2 coins have been flipped so far. Let's go for our third coin, heads or tails, heads or tails, heads or tails, and heads or tails. And the probability each time is 1/2. Our possible outcomes, we can read straight across our tree diagram: heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Our number of successes is our number of heads. So 3 heads, 2 heads, 2 heads, 1 head, 2 heads, 1 head, 1 head, 0 heads. I'm going to turn the slide once you have all this written down. So our number of successes, and the probability of 3 successes is 1/8. You can see that we've got 1, 2, 3 times that we had 2 successes, and 3 times that we had 1 success. Find those totals for the 2 successes and 1 success. So we could have 0 heads, 1 head, 2 heads, or 3 heads. 0 heads, the probability of that was 1/8. The probability of 1 head is 3/8. Probability of 2 heads is 3/8. And the probability of 3 heads is 1/8. The binomial probability formula. N is the number of independent repetitions in a Bernoulli trial. P is the probability of success of each repetition. Q is the probability of failure of each repetition. Remember that Q equals 1 minus P. P plus Q has to equal 1. X is the number of successes that occur. N minus X is the number of failures that occur. P of X equals N choose X times P to the X times Q to the N minus X. Writing out that combination formula, it's N factorial divided by X factorial times N minus X factorial times P to the X times Q to the N minus X. Example 2, a coin is tossed 10 times. Find the probability of obtaining exactly 6 heads. There's our formula. N equals 10, X equals 6. We're flipping a coin, so our P equals 1/2, Q equals 1/2, and we substitute into our formula. P of 6 equals 10 factorial divided by 6 factorial times 10 minus 6 factorial, 1/2 chance, 1/2 to the 6th times 1/2 to the 4th. Multiplying. P of 6 is a 105 divided by 512, which is approximately 0.2051. Example 3, a die is rolled 6 times. Find the probability of obtaining exactly 2 5s. Our formula. Let 5, rolling a 5, be a success. Our number of trials is 6. We're rolling the dice 6 times. We want exactly 2 5s, so X is 2. Our probability of rolling a 5 is 1/6. P equals 1/6. Q equals 5/6. Substituting in. This time notice that P and Q are different, but they do add up to 1. Multiplying. And simplifying. P of 6 is approximately 0.20093. Example 4, a couple plans to have 5 children. Find the probability that they will have more than 3 girls. Write down the formula. This is the binomial probability formula. It will be helpful to put it on a note card. More than 3 girls means 4 girls or 5 girls. Let girl be a success. Our number of trials, they're having 5 children, so N equals 5. More than 3 girls equals 4 or 5. So we need to find P of 4 and add it to P of 5. P equals 1/2. Q equals 1/2. Substituting everything into the formula. First we do 5 choose 4, and then we also have to do 5 choose 5. Simplifying. 6 over 32 equals 0.1875. Example 5. Andrew has a well-established career batting average of 300. If Andrew bats 10 times, find the probability that he will get more than 2 hits. That batting average of 300 is the decimal 0.300. It's going to give us our probability. There's our formula. More than 2 hits means 1 minus 0 hits or 1 hit. We don't want to have to do 2, 3, 4, 5, 6, 7, 8, 9, and 10. We can find just 0 and 1 and subtract it from 1. He bats 10 times, so N equals 10. It says more than 2 hits, so we need to look at x equals 0 or x equals 1 or x equals 2. So 1 minus those values then for finding the probability that he will get more than 2 hits. P equals 0.3, Q equals 0.7. Substituting into the formula, it's going to be 1 minus 10 choose 0 times 0.3 to the 0 times 0.7 to the 10th minus 10 choose 1 times 0.3 to the 1st times 0.7 to the 9th minus 10 choose 2 times 0.3 to the 2nd times 0.7 to the 8th. Simplifying, it's 1 minus 0.02824 minus 0.12106 minus 0.23347. So the probability that he will get more than 2 hits is 0.61723. That is section 11.4, binomial probability.